And welcome everyone to the February 2020 Planetarians Zoom seminar. And today we have Dr. Luisa Rebull and Geoff Holt with a presentation, and they'll lead a discussion on NITARP, which is the NASA IPAC Teacher Archive Research Program, an astronomy experience for astronomy educators. Luisa is the NITARP director from CalTech, Pasadena, California, and Geoff Holt is the planetarium director at Madison Metropolitan School District Planetarium in, guess where, Madison, Wisconsin. Luisa, do you want to take it from here?
Sure, sounds good. So thanks for inviting us. Let me get the presentation going here. So yes, NITARP is the NASA IPAC Teacher Archive Research Program. So sort of the high-level summary. Oh, just so you know, I'm going to do sort of a high-level summary of what NITARP is, and then Geoff's going to talk about his experiences on a team last year, and then I'll wrap up with a couple of slides with specific recommendations for planetarium people who want to apply for NITARP. So the whole goal of NITARP is that educators get a real, honest-to-God, authentic astronomy research experience using real astronomy data, real astronomy tools. Basically what happens is a small group of educators are paired with a mentor astronomer. They have to do the entire research process. So they have to write a proposal, which is peer-reviewed. They have to respond to comments. They do the research, they write up the results, and they take it to an American Astronomical Society winter meeting and present the results in the science sessions. And so they really are modeling the entire research process in about 12 months. We've been operating since 2005, and the main criteria is that participants have to be US-based. We have participants from all over the US, including Alaska and Hawaii, but they do need to be US-based because our funding is government funding. So we'll be recruiting for the 2021 classes starting in May, and the application will be due in September. As part of NITARP, you get 3 trips out of it. You go to a January AAS meeting to start. There's a kickoff workshop that's the day before the AAS. Then you attend the AAS. Then you go home, you work remotely as a team, you write the proposal, you get started working on learning about your science and working on your project. Then you come out to visit us at CalTech JPL for 4 days in the summer. You can bring up to 2 students per educator on that trip. You go home, you keep working, you submit posters to the AAS. And then you go back to the January AAS to present results again with up to 2 students per educator that we pay for. You can raise money for an additional 2 students, but empirically we found that 4 students really is the limit. If you bring more than 4 students, then a lot of your mental energy goes to keeping track of where they're going and what they're doing and what trouble they're getting into. So we do really try to keep that a hard limit. There's a lot of remote work, but you guys are pros at that because we're online remote working right now. In exchange for participating in NITARP, we ask that the educators conduct at least 12 hours of sharing in some way. Professional development workshops, local, regional, national, whatever works for you, just share what you've learned. Historically, we've been primarily aimed at high school teachers. We've also had middle school teachers, community college educators, planetarium educators, but they're the minority compared to the high school classroom contingent. We haven't explicitly forbidden teachers of non-high school kids, but the middle school kids struggle, and our standard model would need some kind of changes in order for it to work, say, with 6th graders or younger kids. So it is mostly high school classroom educators. We are unique, as far as we know, with a combination of these 6 things, plus the fact that we operate in astronomy. So our program is aimed primarily at educators, not students. The T in NITARP is teachers, so we are primarily aimed at the educators. We select participants from a nationwide application process. There's a big misconception out there. One of the top misconceptions about NITARP is that we only work with teachers from Southern California. In fact, we've had a whopping 4 teachers out of 125 in more than 15 years. It's not at all just Southern California teachers. Our participants are we're involving educators on long time scale. So there's lots of education research that shows that in order to affect real change, you need to interact for long periods of time. And we meet that in spades because we work with you intensively for 13 months. Our participants do real research. They're not following cookbooks. It's the real deal. And they have to present their results in the same AAS sessions as scientists. So they're not in a session standing under a sign that says, please be nice to these people. They're high school teachers and students. No, you're standing next to professors and graduate students and postdocs, and you have to defend your work just like everybody else. And our participants are encouraged but not required to involve students throughout the entire process. So the combination of these things, as far as we know, make us totally unique. The teams are made up of a mentor astronomer and a mentor teacher who's been through the program before, and then 3 or 4 new educators, sometimes more, but usually not. They are usually multi-state, they usually cross time zones, and they meet for the first time at a AAS meeting. I love this picture. This picture was from my team in 2008, and I love this picture because they all look like, oh my God, what have I done? I promise you they did great. They submitted 3 posters in the end, presented 3 posters at the AAS. After the AAS, they go home, they have to work on their proposals remotely. They turn in the proposals and they have to respond to the review. And then the final proposals are posted on the web. My teams often do literature reviews in the spring or some kind of basic data manipulation skills. And then the summer's when the intensive work really starts. They have regular telecoms, which usually be weekly or bi-weekly, and there's a lot of email associated with the program, a lot. So you have to have really reliable email to work with this. For the summer visits, you're here for 4 days. You can bring 2 students that we pay for, up to 4. And these visits are really intense. It's usually the first time these folks have worked with this kind of data in anything like this detail. And half of a day is a JPL tour. This is just a picture from the summer visit. And a lot of the kids, working harder than they ever have before. There was one year where on pretty much all of their feedback forms, they complained that you made us work for 8 hours and we only stopped to eat once. So this is an intense experience for these kids. In the fall and winter, the teams go home and finish their projects. The abstracts are usually due in early October, and every team has to submit at least 2 posters, one on the education, one on the science. The science posters are submitted in the science poster sessions, just like everything else. And the posters are up at the AAS for a day each. Most of the people we send annually are the people presenting results because it's the educators and their students. But we've had in recent years a lot of self-funded alumni coming too. So this is a big group shot from the AAS in January, and Geoff is pretty much smack in the middle there. So at this point, I'm going to hand it over to him so that he can tell you about his experience in NITARP.
Thanks, Luisa. I will go ahead and start sharing from my screen.
That was weird. I don't think I took that back from you. There we go.
We see it.
I got it. All right. Well, first thing I would say is that Luisa speaks the truth. Her description of the program is exactly what I experienced. And I would say that NITARP, looking back at all of my other professional development experiences, NITARP is among the best experiences I've had, both from the perspective of astronomy content and concepts, but also in understanding the process of doing astronomy research. And so that has really informed my perspective teaching in the planetarian. These were the adults on our team. Can you see my cursor?
Yes.
Okay, so this is Vin. He's our mentor educator on our team. And then Noah and Andrea were my co-teacher participants. And this is Varjan, our mentor astronomer. Each of us had the opportunity to get students involved. Vin and Noah and I did. This was my team from Madison. I just kind of put the word out to our astronomy club and our astronomy class that if anybody was interested in doing an after-school astronomy research experience, to start coming to meetings and learn more about it. And these are the students that responded. I did not put any mention in there of any possible travel. So they really were signing on for the research experience.
It's probably worth pointing out that the travel involved a trip to Hawaii. So had you mentioned that?
California and Hawaii from a Wisconsin standpoint are both pretty good motivators. So this is our group at the California visit in the summer. Only one of my students was able to join us. The kind of kids that respond to an after-school astronomy research experience are also involved in a lot of other things. But here's Isaac, my student. It was a great experience and it was intense. We spent 8 hours a day in this room, and that was where we really absorbed a lot of that astronomy content and learned how to use some of the analysis software that we were going to use for our research. I almost, like had a heart attack when we saw that our students were going to have to like present to us like right away in that week and go through a PowerPoint presentation teaching us. And they rose to the occasion. It was amazing to see the growth in all of our participants, teachers and students alike. And as Luisa said, we do also get a JPL tour. A couple of the highlights for me was seeing the Mars Yard, where they do test driving for the rovers. We got a chance to see InSight's sister, Foresight. And they were doing testing on techniques to try to get the thermal probe down into the soil. And we got a chance to see the Mars 2020 rover there in the center being put together as well.
It's gone now, unfortunately for our current NITARP group. It's in Florida, I think.
Well, and hopefully on its way around that time.
Yeah.
But here's our team then in Hawaii. That was the other travel experience. This is the whole team in front of our poster on the poster day. Now, in case anybody's interested in the type of research that we were doing, basically what we were doing was mining the Spitzer Space Telescope data archive. And we were looking for objects that had dust around them because sources with dust around them tend to be at interesting stages of evolution, either young stellar objects or evolved stars. And so the name of our team was dust mites, because if we find an excess of infrared from a source, dust might be the answer that's causing it. Anyway, I'll explain a little bit about how we detect that excess infrared. Stars resemble a black body, and if you're familiar with how black bodies work, cooler sources peak at longer wavelengths. And so on this spectral energy distribution, you can see that the hotter the source, the shorter the wavelength of the peak. And for black bodies, they have this kind of signature shape to their tail on the long wavelength side. And for something like a star with nothing around it, it would resemble that black body curve. But if there is something around that star, the shorter wavelength energy coming from the star is absorbed by the dust and then re-radiated at the longer wavelengths that show up as this excess over here of the infrared. And I was like floored by the fact that we could even detect if there was a gap between the star and a dust belt by the fact that it would match the black body curve initially, but then have this excess at the longer wavelengths. Now, for our overall goal for the research, we wanted to put together a catalog of new sources, newly known sources of infrared excess that would be available then for further study by current and future infrared telescopes. And so our first step was to query the Spitzer Enhanced Imaging Products Catalog, that's the SEIP. And our initial result came out with about 500,000 sources. Now, some of you may recognize this image in the background. It's the Axel Mellinger All Sky mosaic. Beautiful mosaic, and it nicely correlates with the galactic coordinates that we have our sources plotted on here. And you'll see why we chose galactic coordinates in just a minute. The next step was to cross-match those 500,000 sources with the European Gaia data release 2. And we found that we had over 2,000 sources that had good parallax data. Next step was to check and make sure that it wasn't a source already known to have an excess of infrared. So that's cross-matching with the SIMBAD database. And then because we're looking for interesting sources, we chose to focus our attention on sources that were outside of the galactic plane. And so that's why you're seeing these as galactic coordinates. It was interesting to have the sources, be selected for outside the galactic plane, because it would be interesting to have sources that are outside of the plane that do have an excess of infrared. And so then our next step in the process was to visually vet the images, just to make sure that the data that we have is not contaminated. So literally for all these sources, we had multiple people going in and looking at the images. And you can see that with the source here on the left in the shorter wavelength channel and in the longer wavelength channel, this is 3.6 microns, this is 24 microns. The source is well-centered. There's no other, sources nearby that might contaminate the data. Over here on the right, you can see in this channel 1, the source seems to be extended a little bit to the upper right. It could be a secondary source there, or it could be an extended source in the background. And so for that reason, and for the way it wasn't centered in the longer 24 micron wavelength channel, those sources were rejected. Well, we wound up at the end with 103 visually vetted good sources of newly found infrared excess. And from that, we wanted to see which ones did have infrared excess. And in fact, 99 of the 103 did. And we were able to detect that using this color diagram, which I can go into more if people are interested. But basically, it's just looking at the ratios of these two wavelengths on the horizontal axis to the ratios of these other wavelengths on the vertical axis. Anything that shows up here toward the top would have an excess in the 24 micron range. Anything over here on the right would have an excess in the 4.5 micron range. Then we plotted our sources on a color magnitude plot, also known as an HR diagram, but in research just referred to as a color magnitude plot. And we were very surprised to find that most of our sources are on the main sequence or near. And so we would love to see if we can get some telescope time with a spectroscope to learn more about those sources if we're able to extend our research. The students and teachers alike were pretty thrilled to be listed as co-authors on this research. And so just, seeing our name in print was pretty eye-opening. Then to also be able to be there then at the American Astronomical Society conference to defend our research and to explain it to people that came by was a very rich experience. And in fact, some of our students listed that as the highlight of the year for them.
Looks like you were listed as first author, Geoff.
Yeah, that's mostly because I was the one that had to submit the information of the proposal and the abstract to the AAS. But that also meant that, yeah, I did have more responsibilities if I was going to be listed as the lead.
Usually we have
Didn't mean
teachers
that I was the
leading,
lead, though.
usually we have teachers leading both posters. One person does the science one, and another one does the education one. And yeah, they're the ones responsible for submitting all of the forms online and getting the poster itself together. And
so that meant that our Madison team did take the lead in designing the poster, just as more of the workload. But the whole thing was a collaboration from our whole team. Here's our Madison team in front of our poster. The experience of being at the American Astronomical Society conference was amazing. To be able to go to the keynotes and just scribble down as many notes as we can about all the amazing things that people have discovered. The press conferences were really fascinating to go to as well. So just in summary, it was, a great experience. Like I said, I had never really done any astronomy research before, and so this was, kind of my chance to see what that would be like, and it was very rewarding. It was great to meet all the other teachers, to learn from Varajan, our astronomer. And looking back on the past year, I just can't believe how much I've learned. Even some of the terms that I've used in this presentation, I wasn't familiar with before this year started.
Excellent.
And
so
now,
you can stop sharing. I'll share to do the last 6 slides that I have. Okay. So the last few slides. So just a few slides with advice for applying if we've gotten you interested and now you want to apply for NITARP. So our oversubscription ratio is more than 5. That means that 5 people are applying for every spot. That means that 80% of the people who apply, we have to turn away. It's my understanding that educational opportunities for, at least classroom educators are not typically like that. But there's a lot of demand for us and not very many spots that we have. So yeah, there's a high oversubscription ratio. Our target audience is educators who are ready for research but haven't done it yet. So if you already have a PhD in astronomy or physics, you already know how research works, so you place out. If you have a master's in astronomy or physics or a degree in another physical science, you might place out. You'll have to talk to us to know. If you've already written a paper and gone to a AAS meeting, you probably place out. Again, talk to us if you have questions. If you do meet all of those criteria, I can, get online with you for half an hour and give you a crash course in IRSA tools to get you up and running, and you can go play in the archives just like you would as a NITARP participant, but faster because you already have a lot of the background that our average participants don't have. This is not a replacement for a master's thesis. There's a reasonable number of people who come to us thinking that we're going to give them a master's from CalTech. No, that doesn't work that way. We help you a lot more than you would be as a master's student, and you do way less math and programming than you would as a master's student. And also you're working in a group, which master's students, normally your master's thesis isn't a group authored production. So if you are looking for a degree, try Swinburne Online. Certainly you can come apply to work with us for a year, but you're not going to have a master's at the end of it. This is also not a way of generating scads of science fair projects. Again, it's a single author thing. Science fair projects are usually single author, and these teams really do work collaboratively as a group. And you're not going to become a science fair project generating machine after working with us. You will use tools and techniques that you can help students with, but this is not, a fast track to the Intel Science Fair. Our application has several long form like essay answers, and there's one specific one that talks about ways that you plan to share the experience. People often, applicants of all sorts, all backgrounds, often underestimate the importance of this section. But for you guys, because you are not necessarily classroom educators, there's a lot of emphasis on ways you plan to share. And when 5 people are applying for every spot, if I can summarize your plans to share with the sentence, I'm sure I'll think of something, It doesn't get you a high ranking. I'm sorry, but it's true. So you need to spell out what it is you plan to do. NITARP is a long-term, in-depth experience. And admittedly, that may or may not be easily integrated into a museum or planetarium setting. Because, you know, in general, you're only seeing people once for a few minutes. So you need to think hard about what NITARP is and how you can share that experience in a way that's unique to you and your environment and your audience. Because undoubtedly, you're reaching people I will never meet in my lifetime. So you need to help me understand how you're going to share the experience. I think there was a chat window. I saw something pop up and now, there we go. Let me see if I can find if there was a chat question. No chat question. Okay. So another section in the application includes ways that you have used real data. So we're looking for people who are ready for research but haven't yet done it. So if you've spent a lot of time playing with FITS images in Photoshop, or you take your own images at your, you know, with your own telescope and using MaxMDL, or if you've actually gotten into some of the tools like IRAS that professional astronomers use, if you've done any of that, explain that. I've had more than one person not mention any of this in their application, and when they got rejected, they come howling to me, but I know all that stuff. It's like, well, how was I supposed to know that you knew all that stuff? So you have to explain that in your application. And especially because you're planetarium folks, you need to make absolutely sure that your management understands what you are doing and why. I can't go into details with this, but you just have to trust me. Specifically in the case of planetarium folks, you really need to make it clear what you're doing and why. And if you have any questions about what you should put in your application or whether or not you're overqualified, just email. Okay, oops, that was weird. Okay, let me get the last slide up here. So the takeaway messages are that NITARP partners small groups of educators with a research astronomer for a year-long research project, and it's the real deal. We model the entire research process from proposal through poster presenting results. We've been operating since 2005, so we've really shaken the bugs out. We know kind of what we're doing now. We work directly with educators and through them students. So if you have a brilliant student, that's awesome, but we work with you first and then you work with the students. Specifically for planetarium folks, you need to explain in your application how you're gonna fit into the NITARP model. Wait a minute, I lost something. I thought, oh, I did lose something. So the T in NITARP is teachers. Even classroom educators are not required to involve students. If you routinely have access to high school students and you plan to involve them, explain that. But I cannot emphasize that enough that you do not have to work with kids. We've had applications from planetarium folks that say, oh, well, I'm gonna get kids out of the woodwork. Honestly, that comes across as a little creepy. If you don't have access to students, don't say that you're gonna find students. Just explain that you don't regularly work with students, so you're not planning on working with students directly with your NITARP experience. And if you think that makes you look bad, trust me, it doesn't. Because if I have to pay for only you coming on 3 trips, that's a whole lot cheaper than you plus 2 students, then you plus 2 students again. So you become a lot cheaper if you're not bringing students. So it doesn't make you look bad, it just makes you look honest. Okay, and then coming back here, you need to explain, you know, in your application how you're going to fit in, whether or not you're going to have students, whether or not you know how you're going to integrate this experience into your environment and how you're going to share. We don't have a big footprint. We've worked with 120 teachers since 2005. So every year we're looking at 6 or 7 new teachers. So we do not have a big footprint, but we do change lives. I didn't have any slides on this, but you know, we've got lots of evidence from lots of participants that say, gosh, this just completely revolutionized my understanding of science, of astronomy, of how this works, of how much data is available, how all astronomers are not middle-aged white guys with bad hair. I mean, all of that comes in. So we're going to be recruiting for the 2021 class later in the spring. The application will probably go out in May. Please do help us advertise, apply if you're interested, and the applications will be due in September, and there's the website. So I thought I saw another question come up.
Yeah,
okay, so there's some questions, I guess, aimed at Geoff.
Yeah, and Alan, do you want to stop here and start the question and answer session, cover the questions during that, or do you want me to answer this now?
Actually, if you think that concludes the main presentation, yes, I think I would ask everybody to unmute and give a round of applause. This has been a really, really great presentation. I like it a lot. Okay, so a round of applause. And I'm going to stop the recording.